In the last two lessons, we dealt with equations where x was part of a sum or a difference. Today, we will deal with equations where x is part of a product, such as 3x equals negative 6. So, sums are where x is being added to something. Difference is where something's being subtracted from x. Product, we're dealing with multiplication now. So here, 3 and x are being multiplied. And we call 3 the coefficient. 3 is the coefficient of x. So the first thing we're going to do is the same as we did before. We're going to model this equation on a sentence map. So we've got 3x. Those are 3 long tiles. Equals negative 6. Okay, in this equation, all of the x tiles are on one side and the integer tiles on the other side, right? So that's kind of what we want. We want x tiles on one side. We're talking about isolating the variable. So it's pretty isolated at this point. It doesn't have any other things with it. But the problem is we have 3 x tiles on one side. We don't want to know what 3 x tiles are. We want to know the value of 1 x tile. We want to know the value of 1 x tile. Since we can divide the x tiles on the left side into 3 equal groups, we should divide the right side of the balance scales into 3 groups. Okay, so let's do that. I'm actually going to arrange these vertically because I think it's easier to see that. So here's 1 group, 2 groups, 3 groups, right? Now, the way I arrange these tiles over here, it actually already kind of obviously shows itself into 3 groups. But I'm going to take these 6 tiles and just sort of put 1 there, 1 there, 1 there. And then I'm going to go back around, 1 there, 1 there, 1 there, right? So kind of matching them up into the 3 groups, right? So now I've got 6 tiles, but they're split up into 3 groups. So now we can match each group on the right side with 1 x tile on the left. So each of these groups has been divided. So this can show us very specifically what 1 x tile is equal to. 1 x tile equals negative 2. So we've been able to solve. Okay, so just some more notes. We use the word divide. Notice we use that word divide. We divided this into 3 groups and we divided that into 3 groups. And this is the way to model division, splitting things into groups of equal portions. Division and multiplication are inverse operations. Division undoes multiplication. So that's why dividing these up is the best thing to do when x is being multiplied by something. You use division to undo it. So now you've seen how we did this modeling it with the algebra tiles. To model it algebraically, to solve this algebraically, we just like we were doing yesterday, 3x equals negative 6, you write the original equation. And now whatever you do to one side, you have to do to the other. But in this case, we want to undo what's happening to x. X is being multiplied. So to undo that, we want to divide. And we're going to use this as our division symbol. Divide by 3. I'm going to divide by 3, just like I divided each side into 3 groups, right? So I'm going to divide this side by 3. But just like I divided this side into 3 groups, I divided this side into 3 groups. So I divided the negative 6 into 3 groups, right? And when I divided that those 3 x's into 3 groups, I was left with 1 x, right? And when I divided the negative 6 into 3 groups, I was left with negative 2. That's what went into one group, left negative 2. So see, either way, we get the same answer. And then we check our answer Remember, to check your answer, you just plug it into the original equation. So instead of writing 3 times x equals -6, we write 3 times -2. And remember, don't use an x for your times symbol because it'll look like a variable. Either use parentheses or a dot. 3 times -2 equals -6. Is that a true statement? Does 3 times -2 equal -6? Yes, so we know we solved the equation correctly. But what if the variable has a negative coefficient? Now remember, coefficient meant that number that's being multiplied by the variable, right? So here 3 was a positive number. What if we end up being multiplied by a negative number? Like in this case, -2 times x equals 16. Okay, so again, we're going to just model it the way we started off, but so we got 2 x's on this side, but they're shaded, and then we got 16, 11, 12, 13, 14, 15, 16, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, let's see, 2, 4, 6, 8, 10, 12, 14, 16. Oh, I draw too many. 2, 4, 6, 8, 10, 12, 14, 16. Okay, so just ignore that one. So, again, we want to know the value of 1x, not the value of 2x tiles, and not the value of a negative x tile. So before we divide this into groups, we're going to take the opposite of both sides of the equation. The opposite of both sides of the equation, okay? So we want to take the opposite. So long as what you do to one side, you do to the other. It will keep the scales in balance. So this is another thing that we're learning we can do. We can take the opposite, right? So I'm going to take the opposite. So instead of drawing 2 negative tiles, I'm going to draw 2 positive tiles. And instead of drawing these, so the shapes are going to stay the same, but the colors are going to be different, right? So and now, once I do this, I can solve the equation just like we did in this example up here. Okay, once I have positive x tiles, right? I can divide them into groups. And notice I already arranged it vertically. So here, these 2 are vertical. So 1, 2 algebra tiles. So I'm going to split this side. And then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I divided them in half, right? Right down the middle. So I sorted this side into 2 equal groups, and I sorted this side into 2 equal groups. So now I know what 1 x tile is equal to. 1 x tile is equal to -8. So the only extra step here was taking the opposite of both sides and then doing the division, right? So showing this algebraically, we would write, again, -2x equals +16. But remember, it was 2 steps this time. First, we took the opposite of both sides. So the opposite of -2x is +2x. And the opposite of +16 is -16. And now we have x being multiplied by 2. And what we want to do is we want to divide this side into 2 groups. And whatever we do to one side, we have to do to the other. So we divide this side into 2 groups. And 2x divided into 2 groups just leaves 1x, right? 2 divided by 2 is 1. And -16 divided by 2 divided into 2 groups is -8, right? It makes 2 groups of -8. So we have x equal to -8. So either way, we get the same answer. And now we check our answer by plugging that -8 into the original equation. So -2 times, and we're going to try -8 in there, equal +16. Is that true? We know 2 times 8 is 16, and a negative times a negative is a positive, so this is a true statement. So we solved correctly.